I is equal to integration of x plus 1 divided by x into x square minus 4 into dx. As this is again a rational fraction with a factorized denominator, so we take it separate. Now we check the factors in denominator. As there are two factors, first is x, second is x square minus 4. As power of x is 1, so it is called linear factor, which does not have factors. Now again, which cannot reduce it up. Now x square minus 4 is a quadratic polynomial. As we know, quadratic polynomial has two linear factors if it factorized. As this is in form of a square minus b square, as we know a square minus b square has two factors, a minus b, a plus b. Similarly, this quadratic factor can be factorized. So in partial fraction, take as many factors in factors of denominator you can. So you get simplified rational fraction. Now for that we take the factors of this quadratic factor. As first factor is x, it remains as it is, and quadratic factor has two linear factor. First is x minus 2, as 4 is the square of 2, and second is x plus 2. So denominator contain now three linear factors. Now we can partial fraction. We get partial fraction of this rational fraction with three unknown constants a, b, c. The first partial will be a upon first linear factor x, plus second partial will be upon second linear factor x minus 2, plus third partial will be c upon x plus 2. Now to evaluate a, b, c, we multiply by x, x minus 2, x plus 2 on both sides. So we get x plus 1 on left hand side, and on right hand side in numerator a we get x minus 2, x plus 2 in multiplication. In second term numerator b we get x and x plus 2 in multiplication, and in last term the numerator c get x and x minus 2 in multiplication. We put this as a number 1. Now putting the values of x, we get the unknown a, b, c. As b and c is a contain common factor x, so we put x as a 0. So on left hand side 0 plus 1 is equal to, on right hand side a into bracket 0 minus 2, and second term will be 0 plus 2. As term of b and c will become, c will eliminated or take it as a 0. So 1 is equal to a into first bracket we get minus 2, in second bracket 2, so 1 is equal to minus 4a. So value of a will be minus 1 upon 4. You can simplify this, you can understand this. Now to take the value of b, we check common factor in term of a and c. As there is a x minus 2, so we put x as a 2. On left hand side we get 2 plus 1. On right hand side term of a will become 0, and in term of b we get in first bracket 2, in second bracket 2 plus 2, and term of c will again become 0. So 2 plus 1 is equal to 3, and 2 into 2 plus 2 4, 4 into 2 8b. We get, actually we simplify this as b into first bracket as remain 2, and in second bracket 4, so 3 is equal to 8b. So b is equal to 3 by 8. Now the value of c. For that we check the common factor in a and c, a and b, which is x minus 2. So we put x is equal to minus 2. Actually x plus 2 is a common factor in b and c. So on left hand side minus 2 plus 1, on right hand side term of a and b terms are eliminated, and in term of c, in first bracket we get minus 2, in second bracket minus 2 minus 2. So minus 2 plus 1 minus 1 on left hand side, and c is multiplied by minus 2 and minus 4. So minus 1 is equal to minus plus 8cs. Therefore c will become minus 1 upon 8. Now using this constant, we rewrite the required partial fraction. As given fraction was x plus 1 divided by x into x square minus 4, in which we have quadratic polynomial quadratic factor, which is again factorized into two linear factors. So we get three partials. In first partial we have a constant 1 by 4 with linear factor x. In second partial, constant 3 by 8 divided by second linear factor was x minus 2, and plus third constant minus 1 by 8 with linear factor x plus 2. Now take integration of this rational fraction with respect to x. So x plus 1 divided by x square minus 4 dx. On right hand side we get 3 integral with constant in first integration constant minus 1 by 4 outside integration, in integration 1 upon x plus 3 by 8 is a constant in second integral with integral contain 1 upon x minus 2, and in last minus 1 by 8 take outside integration and integration contain 1 upon x plus 2 dx. Now this on left hand side we put r I as we take it as I, and in right hand side in first 1 by minus 1 by 4 actually 1 upon x is the integral of has the integration log of x plus 3 by 8. Now this is a linear term in denominator, so first in the second integration will be log of x minus 2 as coefficient is a 1, and in last 1 by 8 log of x plus 2, and remember to put c. I is equal to integration of 1 upon x square plus 4 into x plus 1 dx. As here also a rational fraction with a factorized denominator is given, as there are two factors. First is a quadratic as there is a term contain x, and second is a linear. But you can see here is a quadratic polynomial is in form of a square plus b square which has no factor. That means this is a irreducible quadratic polynomial. As we know, irreducible quadratic polynomial can partialized using two unknown constant. If a and b are used, then we put them as a ax plus b, or b and c are used, then we put them as a bx plus c. Now we use a and b, so the partial of quadratic polynomial is a having constant. Using a and b in numerator we put ax plus b, as this is a linear form. As you can see, x has a power 1, so a and b put in linear form ax plus b divided by irreducible quadratic polynomial, that is x square plus 4, or quadratic factor x square plus 4. Now second is a linear, so we have to take only one constant. As a and b are used, so we take c divided by linear factor x plus 1. Now we have to find values of unknown a, b, c. So multiplying by x square plus 4 x plus 1 on both sides. So on left hand side we get 1, on right hand side in first term numerator is a ax plus b, so we put it in bracket and multiplied by x square plus 4 cancel, so we get only x plus 1, and plus in second term numerator is a c and we get multiplier as a x square plus 1. We put this as a number 1. Now we have to find a, b, c. As you can see here, term of a and b is in bracket, so they can't separate out. So to find the value of c, we can take the term in product x plus 1 such a way it become for any x it becomes 0. Now you can check for x is equal to minus 1, this bracket will become 0. That means term of a and b are eliminated, so we get value of c. So we put first minus 1 as x. So on left hand side there is a 1, on right hand side first term will be eliminated, and in second term c into bracket minus 1 square, as x square is there, plus 4. So 1 is equal to c into minus 1 square is always 1. 1 plus 4 is a 5. That means c is equal to 1 by 5. So we get the value of c. Now how to find the value of a and b? As we know, a and b cannot be separated out. So in that case we use the values of x and the constant which we already evaluated. We have evaluated value of c, which is 1 by 5. Now value of x, any value can be taken. Now we start with the value 0. As we take only x as a minus 1, so we can take here x as a 0 and c as a 1 by 5. By putting these values in equation, on left hand side we get 1, on right hand side in first bracket as x is equal, term of x will become 0, so x becomes 0 plus b, and in second bracket also term of x becomes 0, so 0 plus 1 we get. In second term, as c is a 1 by 5, put it as a 1 by 5. Now in bracket x square becomes 0 and we get only plus 4. Now 1 is equal to, in first bracket we get b and second bracket we get only 1. And now in this last second term 1 by 5 multiplied by bracket become 4. So 1 is equal to b is equal to 4 by 5. Now this 4 by 5 take on left hand side, it take as negative. So simplifying this we get b is equal to 5 into 1, 5 minus 4, 1 divided by 5 again. So b is again 1 by 5. Now to evaluate c, we put another value of x. As we take value of x as a -1 and 0, so we take x as a 1 and use the constant which we have evaluated. That is value of b again 1/5 and value of c which is again 1/5. Now equation 1 becomes on left hand side as 1, on right hand side as we don't know a, so we put a, but x has a value 1, so we put it in bracket, and the value of b which is a 1/5. Now in second bracket again x is a 1 plus 1. Now in second term as c is a 1/5 and in a bracket actually 1 square plus 4. Now simplifying this, on left hand side it is a 1. Now a into 1 a plus 1/5, it remains as it is. Now 1 plus 1 is 2 and plus 1/5 into 1 square 1 plus 4 5. And now simplifying, 1 is equal to 2 into bracket by bracket multiplying 2 into 8 2a plus 2 into 2/5, and here 5 get cancelled, we get plus 1. This plus 1 we take on left hand side, it become -1, so -1 is equal to a plus 2/5. Actually plus 2/5 also can take on right hand side, left hand side. So on left hand side 1 minus 1 0 and plus 2/5 become -2/5 is equal to 2a. Now 2 get cancelled, so we get value of a as a -1/5. So a, b and c are evaluated. So required partial fraction now we can rewrite. Now therefore required partial fraction as given fraction was 1 upon x square plus 4 into x plus 1. Now putting the values of a and b and c, we get value of a was -1/5 x plus value of b is 1/5. So a and b are used in form of linear term of x divided by quadratic factor was x square plus 4 plus the value of c is 1/5 divided by linear factor is x plus 1. Now taking integration with respect to x, we get integration of 1 upon x square plus 4 into x plus 1 dx. On right hand side there is the addition of two terms, so we take integration of first term, that is -1/5 x plus 1/5 divided by x square plus 4 with respect to x, and in second term 1/5 is constant, so integration of 1 upon x plus 1 dx. As you can see in first term, as on left hand side we take I, but in right hand side in first term there is an addition in numerator, so we can't take any constant out of integration, but we can use a algebraic symbol for a plus b divided by c. As you can simplify this as a by c plus b by c. We state that if addition is there in numerator and denominator is common, we can separate the denominator. Similarly, addition is there, so we can simplify this as a -1/5 x is a numerator of first term with denominator again x square plus 4 plus second term has a numerator 1/5 with denominator x square plus 4 into dx plus 1/5 into integration of 1 upon x plus 1 dx. We take it as it is. Now here is in addition, so by rule of integration we can take separate integration. Now in first term -1/5 we can take outside integration as it is a constant multiplied in product. So in integration we get only x in numerator divided by x square plus 4 dx. Now in second term also 1/5 is a constant which we can take outside integration, and in integration we get 1 upon x square plus 4 dx plus 1/5 integration of 1 upon x plus 1 dx remain as it is. Now next, as this is again a proper fraction, you can check the derivative of denominator as it is a 2x and in numerator we have only x, so we can adjust 2 in numerator so that we get the form of integral f dash x upon f of x. That means derivative of denominator is in numerator. So to adjust 2 in numerator we take 1/2 outside integration, and integration we get 2x 2 in numerator divided by x square plus 4 dx plus 1/5 into integration. As this is again a proper fraction with numerator and denominator is a quadratic free of term of x, so this is a radical form. As coefficient of x square is a 1, so we take constant in square form. So 1 upon x square plus 4 is the square of 2 dx and plus 1/5 integration of 1 upon x plus 1 dx Now we take the integrations. Okay, so this first term will become minus 1 by 10. Now by using integration of f dash x upon f x, which has the integration log of denominator log of f of x plus c, so integration of this integral will be log of denominator x square plus 4 plus 1 by 5 as it's constant. Now this is a form of 1 upon x square plus a square. As there is a square addition of squares, then the integration is in term of tan inverse. So in integration with radical a, we get 1 upon a, that is 1 upon 2 tan inverse x upon a, that is x by 2, and plus 1 by 5, and last integral is 1 upon ax plus b form, that is having integration log of x plus 1 as coefficient of x is a 1 plus c.